For this next section, we're dealing with radical equations. Basically, they're equations that involve some sort of square root. Now this section includes cube roots and fourth roots and other things, but I'm going to try to stick to only square roots to solve. And I'll do my best on my math lab to keep the homework focused on just the square roots. That's all I'm really concerned with here. So here's the idea. On a radical function, you're looking for, or a radical equation, you're looking for the number, this is a real basic one, the number that when you take the square root of it, you get 5. Okay? And so I think you probably all recognize what the answer is going to be here. What numbers, the square root of what number is 5? Well, the answer is obviously 25, right? Now, how could you get 25 from 5 if you didn't just know that, if it was a little bit harder numbers to deal with? Well, the answer is you square both sides, right? If you square a square root, you get rid of the square root. And if you square the 5, you get 25. And so one thing we're going to do to solve these radical equations is we're going to raise both sides to the second power, or square both sides. Okay. Now that's seems just simple enough. It seems like you should be able to do that, because in an equation we tend to say whatever you do to one side you have to do to the other side, right? And that's fine. The problem with radical equations is this: when you square a number, and it could be any number, it doesn't have to be just a root. When you square a number, you introduce, or square both sides of an equation, you introduce the potential for answers that don't actually work. It is a kind of a downside to this, and so you really do need to check your answers here. I'll try to show you some examples shortly that where the answer we come up with won't actually work in the original equation. Okay, so the main idea is this. There's several steps, and I want to break down the steps for you. So the first step is you need to get a root by itself. There are some times where these equations have many terms, and if you don't get a root by itself, then when you square it, it won't disappear. It'll end up still in there. I can go through and show you that later, but the main thing is you must isolate one radical. Okay, you have to make sure that one radical is by itself. Alright, then you're going to square both sides. Okay, so that's the key step right there, is to square both sides. And then the third step, now there are going to be some cases or some examples where you actually have more than one radical in the problem. And so it may be the case that by squaring both sides you don't actually eliminate all of the radicals, you only eliminate the isolated one. And if that's the case, then you repeat steps 1 and 2 until there are no more radicals. So that's the next step, is to repeat 1 and 2 until there are no more radicals. So you isolate radicals, square both sides, continue that process till all the radicals are gone. This step may not need to be done. Okay, you may not have to do anything there. And then the fourth step is to solve the resulting equation. Okay, and then step 5 is to again check your answers. Check possible answers. Again, just like we saw with rational equations in, what chapter was that? Was that chapter 5? No, chapter 6? We did rational equations at some point. Maybe we didn't. Maybe we haven't done those yet. I don't know. But anyway, or was logarithmic equations, that's what it was. We saw that there were some possible answers that didn't work. Okay? Alright, so those are the steps, and now let's do a few more examples. We'll make them a little bit more complicated gradually. I'll do a couple more in this video, and then we'll do a second video. Maybe a third if necessary. And so let's try one where we take the square root of, let's do 3x minus 2 minus 5 on the outside of the root equals 0. Alright, so here we're going to go through the steps. We have to isolate a radical. There's only one in the equation. I want to get that by itself. So anything outside the radical I've got to move. Get it to the other side. So here I get the square root of 3x minus 2 is equal to 5. We're then going to square both sides of this equation because I got the root by itself. So square the left, square the right. And in doing so, there's potential to introduce extra solutions. Okay, so I square that. The square root of the square of a square root disappears, and you just have the stuff underneath. The other side, 5 squared is 25. Okay, we don't have to repeat because there are no more radicals. Number 4 is solve the resulting equation. So this one's just a simple linear equation. Add the 2 to both sides. You get 3x is equal to 27. Divide by 3, and you will get 9 as your answer. Again, you should always double check with the original equation to make sure that works. So my check over here off to the side, I'm going to have a square root of 3 times 9 minus 2, and then a minus 5. So that's my left side. Now I want it to equal 0 for this to work out. And of course, under the root we get 27 minus 2, which is 25. When I subtract the 5, this is going to be 5 minus 5, which does equal 0, so that works. So my final answer is going to be the number 9 in set form, solution set. Okay? We'll work through a few more difficult examples in the next video.